Okay, so let's get started on this final time that we're going to be meeting. That you're going to be meeting with me. Next week is R&R, and if you want to meet with me, you can email me, and I will be in my office most of the week, and I can set up a time to meet anybody. Colin and Eric, you're going to meet with students when? Okay. So one of the things that I've noticed since I started teaching this class, or since I started making available my lectures online plus this, is that I get a much smaller attendance, which I don't mind. But I actually do mind today that a lot of students haven't turned up because they have to rate the course. So it's a problem that they don't get out to fill out these forms. Do you think it's a good idea to do this and to allow students the option just to skip the whole class? Seems a little crazy. Become more like a MOOC then, except there aren't as much in the way of supported visuals because it's only my voice that comes across. Anyway, so be it. I thought I would just get some feedback from you. So how many of you actually go and listen to the lectures? Or is it only for people who don't come to the class that go listen to the lectures? Okay. Yeah, so I thought it would be a good idea in case you miss a class and you want to make up or you miss a couple of classes, but it clearly means now that some students don't come at all. Yeah. Yeah. Right, so if I want to have video, then I've got to pay several $1,000s to do that. Yeah, so they will arrange it, but there's no point in doing that unless I really organize it properly to pay that kind of money and then turn it into a MOOC. But then if I do that, then why bother? Why should I come to class anymore? I can just do the stuff in a studio and then answer students' questions. But obviously, the way education is going, I think in the end, students will take a much larger proportion of their courses online and do so maybe at a junior level, and it may help to some extent control the cost of education. Because if you don't come to a place like Cal for 4 years, but you only come for 2 years, then you take a lot more stuff online, then it costs less. But I don't know if some of you saw there was a blog that one of the professors was talking about the cost of education here. And of course, the cost of education here is still well under half of what it would cost to go to a private school. Cal, as a college, not as a research institution, is the highest ranked public university, and it's kind of ranked about 20th, whatever these rankings mean. And so you still get an outstanding education comparable to a private institution, and you're paying a lot less. Now, I know students are hurting a lot because fees are going up. So the question is that appropriate? So we have three choices. Either students can pay more and appreciate the quality of education that they're getting, or they can say, we want to maintain the quality of this education, but we don't think we should be paying. The taxpayer should pay more of it. Or we could lower the quality of education. So what do you guys think about these different options? Which is what? Yeah, so we don't seem to be able to persuade the general public, particularly the Republican Party, that taxpayers should be paying more. And I don't know how many of you know this, but in about 2000, the state was paying a quarter of the bills at Cal. Now they're paying 8%. And if you go to schools like Stanford, Harvard, Yale, and some of those others, they have very big endowments. Now, there isn't the same ethic about giving back to the school at a public university that there is at these private universities. So, Harvard and Stanford, their endowments just completely overwhelm the kind of money that we get from alumni giving. So the money has to come from somewhere. I don't know how many of you are aware of this, but every time when we have research, when we get research funding, like from the National Institutes of Health, the National Science Foundation, and so on, the university charges an overhead. And so if in my research program, I apply to the federal government, USDA, National Institutes of Health, or National Science Foundation, and I get a grant, say, for $1 million to do research for the next 4 years. Then the university charges 57% on top of that, so they get $507,000. So there's a huge chunk of money that comes from the federal government via research contracts when the faculty do research. And as a research university, Berkeley is one of the top universities in the world. And we do very well, except we're not quite as competitive as universities that have medical schools, because there's by far more money coming into research through medical channels than through, say, the National Science Foundation. And so I guess the two big channels are either through the military or through the National Institutes of Health. So that's how we get some of our funding. And a greater and greater proportion is being picked up by the students through their fees, and a smaller and smaller proportion is coming from the state, and then there's gift giving. So we don't do very well at the state level, not nearly as well as we used to. And in terms of gifts, we don't do well as some of the private universities, the big private universities. And we don't charge as much in fees. So we really are at a huge disadvantage when you look at, say, a school like Stanford or Harvard. They don't get the 8%, but the fees are much more, and they get much more in the way of gift giving. So you can expect public education it's very difficult for public education to hold its own. And so what will happen is the third option, and that is education is has the potential to really go down at a university like Cal and other public schools compared to private schools. So you guys need to think about that, because it is a problem that needs to be solved. And obviously, your generation going out there have to think about how do you value public school education and what do you do about it. Anybody want to make a comment? Okay, that aside, most of you are concerned about getting jobs when you leave here, and hence doing well in your coursework, and as part of that, doing well in the final exam. So the final exam is going to be like the midterm. And the emphasis is on testing your understanding of the material. So the emphasis is not going to be on whether you can integrate a complicated or differentiate a complicated function. And you won't have to differentiate anything more complicated than an exponential. Everybody knows how to differentiate an exponential, I hope. And then there may be, in some of the questions, a little bit of algebra. But mainly, it's testing your understanding of the material. Now, in the same way that I try to encourage students to do well, or help them do well on these written exams, I'm going to give you one of the questions which you can prepare at home. So the question you prepare at home is the Gordon-Schaefer kind of analysis, the economic analysis that we did early on. So this was around lectures 8 and 9. So you have to go back to that transition period from the material that was mainly in the first, in the midterm, and then material for the final. So that's kind of where we start with this equation. So we've seen this equation many times. It's basically the x dt is equal to f of x, where f of x, in most cases, when we discuss this thing, we were thinking of the logistic model. And when you look in different places to see this theory, very often it's developed in the context of the logistic model. But we don't need to specifically use the logistic model because I'm not asking you to calculate specific expressions. I'm just asking you to draw diagrams. So what I say is that you have f, which basically satisfies the properties of a logistic model, which is f0 is 0 and f at k is 0, and that it has this convex shape, so it has this hump shape. So if you draw f of x versus x, then you'll basically get this curve. And this curve is f of x versus x, and then you can draw the other term in this equation, which is v times x, and then you do the equilibrium analysis, and you do the yield effort curve, and you've seen all that material, and I expect you to work through it, and it's going to be for 1/5 of your final total, so you've got 3 hours, which is 180 minutes. So you shouldn't devote more than 35 minutes to presenting, to answering this question. And I expect you to answer it. A lot of points can come from having good diagrams and then making your points very succinctly. So I don't expect you to write long sentences. I'm sure Eric and Colin don't want to read long sentences. They just want to see that you understand the stuff, so you can put things down in point form. But if you put something down in point form, don't put half the point down and expect to get full marks for it. If there are some connected ideas, they all have to be put down and the connections have to be made. You just don't have to write it out in long sentences. And if you want to abbreviate things, then go ahead and abbreviate as long as it's very clear what you're doing. So I ask you to discuss, so with the aid of carefully labeled diagrams, I want you to discuss things like the two situations. One's the common pool, one's the sole ownership. Under the common pool, you get the bionomic equilibrium where no profit is being made. Under the sole ownership, you're talking about maximizing profit. So there's concepts such as maximum sustainable rent, maximum sustainable yield. There's the bionomic equilibrium, and there's also discounting. And so if you want to, when I say discuss it, rather than writing a paragraph, if you sort of have like a little heading common pool, and then you have some notes there on what the common pool is, and you refer to the label diagram, whatever, and then you have a little heading sole ownership, and then you have a little heading MSY, and then you discuss it, that's fine. So you can arrange your answers in this kind of point form with the diagrams and so on. But all the information must be there and must be cross-referenced properly. So just because you have a point down and you don't connect it to anything doesn't mean you'll get credit for it. You have to say why it's there and what it means in the context of your diagrams and so on. Are there any questions about that? So you have the opportunity. So think of it this way. There's going to be 6 questions. This one's for 30. If you do your preparation, you're going to get at least 28 out of 30 for this. There's some other questions that you don't know exactly how I'm going to phrase them, so you might not expect to get 28 out of 30 for them. You might only expect to get 23 out of 30. Remember, most people who get A's in this class do not get 120 out of 150 for this exam. They don't even get 100. And that's because you have to get 80% for an A, and some of you have been averaging, like 22 out of 25 for your homework. Okay, so when I say know how to add, subtract, and multiply matrices, you just need to know this in the context of 2x2 matrices. There won't be anything bigger than a 2x2 matrix, and you need to know how to find the eigenvalues and eigenvectors for the 2x2 matrix. And in your textbook, there are work examples if you want to practice. So there's opportunities to practice if you need to practice. Now, the Leslie matrix model is going to be important. And if I give you a life table, and it looks like it's going to lead to a 3x3 Leslie matrix model, then you're heading in the wrong direction. Remember, x0, which are the newborns, doesn't appear directly as a variable in the model. The variables like x1 and x2. And if you're getting an x3, then you haven't taken into consideration the fact that x2 means individuals age 2 and older. So you're not going to get anything more complicated than a 2x2 problem. Now, when it comes to the Leslie matrix, the Perrin-Frobenius theorem is the key idea in the Leslie matrix, because the Perrin-Frobenius theorem tells you what? What is the Perrin-Frobenius theorem? What's the value of the Perrin-Frobenius theorem? Anybody? What does it tell you about that matrix? Why did we even talk about that theorem? What did we use it for? So we used it to conclude what's going to happen in the long run with this model. So in the short run, if you have a Leslie matrix model, you don't know what's going to happen unless you multiply and you calculate. You have an initial population, you can calculate where your population is going to be at time 1, you can calculate where your population is going to be at time 2 and 3. And in the textbook, if you think of the Impala example, that bounced around, but then eventually it started to head off in a particular direction and grow at a particular rate. What does the Perrin-Frobenius theorem tell you? It tells you what? Right, but what does it tell you as time approaches infinity? What does it tell you about the population? Yeah? Well, if the Perrin-Frobenius theorem holds, that is, if the matrix is what's called a positive matrix, if it's a positive matrix and you can find some power of it so that all the elements of the matrix are non-zero, then it tells you that you've got a stable age distribution. So it's not stable in the same sense of going to an equilibrium number, but it goes to an equilibrium distribution that tells you the stable age structure. So it tells you the relative number of individuals in each age class, eventually what's going to happen. What else does it tell you? What does it tell you about how the actual numbers are changing? What does it tell you? Yeah? Well, they're either growing or declining. So it tells you about, the proportional growth or decline with time. What do we call that? How do you find out from the Leslie matrix, what that growth rate is going to be, or that decline rate is going to be. Which eigenvalue? The 2. Now, one of them, non-trivial means one of them is 0, so dominant. The one in its absolute value. But if the matrix is primitive, that is, if you take a positive matrix in all its elements, you can find a power such that if you raise it to that power, all the elements are non-zero, then you know the dominant eigenvalue, the one with the largest absolute value, is also positive. So it tells you what that rate of growth is. If that rate of growth, the dominant eigenvalue is greater than 1, the population is going to grow, and if it's less than 1, the population is going to decline. And then it tells you what the stable age distribution will be. So you need to know and articulate that. I don't know if you're just scared to articulate it here in case you get it wrong. I hope that's the case. And if you don't know it yet, I hope you know it in 2 weeks. And if you don't know it in 2 weeks, then you can wave or kiss goodbye 10 points. So you better know it. Okay, so how do we go about building linear compartment models and very simple linear compartment models? So just review that stuff. Review the stuff about, so linear models, we know the solutions to linear models because linear models, the solutions are just expressed in terms of exponentials. So for a linear model, how do we find the exponents in which we express the solutions? How do we go about and find what those exponents are? Let's say we've got a 2 by 2, two-dimensional system, linear system, and we want to know what the 2 exponents are. How do we find them? Yeah? Well, what did you say? Something to do with? Well, it's got something to do with finding the determinant, but it's more than that. Why do you want to find the determinant in this analysis? Right, so you find the eigenvalues. Okay. So now in the nonlinear, how do you analyze the system, a 2 by 2 system? So in the nonlinear system, you can't express the solution as a sum of exponentials, and in some cases you can't integrate the solution. You can always use NOVA to simulate the solution, and we did a number of those in the work sets. But given that you're not using NOVA, it's in 2 dimensions, then we use the phase plane method. And you're going to get it, and you're going to get a couple of, you're going to get competition, you're going to get predation, and you're going to get epidemics to look at, and you need to understand them all. You need to, when it comes to models of epidemics, don't worry about the very complicated models, just worry about the simple basic models and understanding SI models, SIS models, SIR models, and so on, and the basics of those. Okay. So when you do a phase plane analysis, okay, so actually number 7, before we discuss that, just make sure that when we write down nonlinear models like the Locker-Volterra prey-predator or the Locker-Volterra competition, or if we write down one of the epidemic models, that you understand that in those models on the right-hand side, there's either 2 terms or 3 terms, depending on how complicated the model is. What do each of those terms mean? So don't just look at the equation, take out an equation and say, oh, this bit models the growth. This bit models how the predators are extracting the prey. This bit models exponential decay of the prey. Or this bit models intraspecific competition. This bit models interspecific competition. So you need to understand all those components of your model. Now, in a phase plane analysis, you have the null clines, and then you also have the equilibria. And the null clines, and then drawing the arrows in the different segments of the plane that are kind of marked off by the null clines, you can kind of see what happens. Is the solution going around the equilibrium? Does it look like a saddle point? Does it look like the solution is just going straight in or coming out? Now, the way to check that is that if you have a nonlinear model and you have one of its equilibria, then if you want to know, is it a stable or unstable spiral? Is it really a spiral? Is it a saddle point? What you need to do is you need to take your model. Here's your model. And I'm going to make this bigger. So there's your model written down in general terms. In most cases, we wrote down the model in terms of x and y. Here I've got the model in terms of x1 and x2. Now, in order to find an equilibrium, we have to solve for f1, x1, x2 equals 0, and f2 of x1, x2 equals 0. The first equation equals 0 gives you the x null cline, x1 null clines. The second equation gives you the x2 null clines. Where they intersect gives you the equilibria. Very often, like in the prey-predator models or the competition models, you can actually solve for these equilibria. Once you solve for an equilibrium, you can call it x hat. Now, we've seen that in these models, there's not only one equilibrium. Very often, there may be 2 or 3. Some of the equilibria might be on the axis. Some might be on the origin. If it's not the origin, then that means x1 equals 0, x2 equals 0 is an equilibrium. That's typically there because populations very often they can't spontaneously grow. They can, of course, increase or decrease if individuals come from the outside. So if you've got migration in there, then x1, 0, x2 equals to 0 is not necessarily an equilibrium. But if there's no migration, then very often it's going to be. But then there's also an equilibrium where very often if x1 is 0, x2 might go to an equilibrium. So that will be a point on the vertical axis. Or if x2 is 0 and x1 goes to an equilibrium, that will be a point on the horizontal axis.